Welcome, everyone, to Mark Voids a Warranty. I'm Mark, and we're here to finish tearing apart that ginormous broadcast lens that I had last time. That thing was a lot of fun, and I learned quite a bit, but there's still a little bit more to do. One, we've got an aperture ring that's got some mechanicals in there that might be interesting. Two, there are encoders like this all over the place in this design, and they show circuits for a resistive element in there. So I'm kind of interested to see what exactly this is, because otherwise I would expect that to be a true quadrature encoder. There's this high voltage box. I'm not really sure what it does, but we completely forgot about it once we removed it, or at least I did. And then the interesting thing is this guy. This is some sort of sensor that goes in the lens, and it's got all sorts of adjustability to it. I'm just kind of interested to know what exactly that is. So we'll start with one and then we'll move on to the other. If you have any questions as we go through, please feel free to ask them. And Brian, thank you for joining us and spending what time you can. So we're going to start right here. This is the high voltage doohickey. I don't know how high voltage it is, but I know it says high voltage. So if you weren't able to catch all 3 hours of Mark Voids a Warranty last week, or 2 weeks ago actually, we took a week off, I'm getting that edited down to something a little more approachable, so the barrier to entry isn't quite so high. So right now there's just some small case screws. The case itself feels relatively substantial. I don't know what gauge metal that is, but I mean there's no give to this thing. It's got a slight draft to it, almost like it was casted, so the base of it was probably cast in something. So we've got a top plate with some holes for adjustability. Again, the part that always blows me away is all this stuff is pre-CAD. They would have created all of this on drafting tables. Some pins that go through, these actually screwed this component down to the case. So they did, the two ways that you generally do this, one, you use a short screw and you just have the technician stick the screwdriver through, or in this case, they had these things go all the way through, but just a very, very small amount of bite. So here we go. This is our high voltage section circa 1980. Just an interesting connector that's got a combination of some high voltage and low voltage connectors. Traces that were all hand wrapped. You just don't see that kind of trace routing anymore with today's modern CAD packages. They're kind of hard to note, but you can see some, oh here, you know why they're hard to note? Because I'm on the wrong camera. But we've got some binding posts for taps. Looks like a duty cycle adjustment. Frequency adjustment, and you can see a little bit of potting there just to lock everything in once they had this thing tuned. A couple toroids. Looks like they made some attempts to orient them correctly, but not a lot. So, all right, well, let's pull this thing out and see if there's anything interesting underneath, shall we? I'm going to go back to the wider angle. Again, as we go through this, if you do have any questions, please do ask. This is a continuation of the teardown from 2 weeks ago, the giant production lens. I actually went back to Apex yesterday. I had lunch with a buddy in LA, and Apex is up in Burbank or maybe even Sun Valley. I'm not really sure. So I stopped by, just kind of walked around. I did find something to take apart once we get to 1,000 viewers. However, I can't do that alone. I actually need your help to make that happen. So I'll share that with you in a little bit, but if you want to see that the next thing taken apart, you've got to share this podcast or this whatever I'm making with your friends, with your neighbors, with your friends' neighbors and your neighbors' friends. That's the only way we get more subscribers. And then if you haven't already, please make sure that you like and subscribe. All right, a couple more screws on the bottom there holding stuff in. Hopefully that lets stuff go. We've got a couple screws on this really interesting connector. Looks like I'm going to have to get something to pop that connector first before I can do anything else. I'm going to grab some tools. One moment. Okay. Sorry about that. Wasn't anticipating having to use these today. Wrong size. This one looks a little small, but it might just be the right size. Yep, it is. So now I need to hold that in place with my Van pliers. These are wonderful little pliers. All sorts of useful. There we go. Okay, those binding posts are gone. Now it should be possible to remove this, although we might be out of luck after that. We'll see. The entire assembly is just top-notch, though. I mean, the wires are stripped perfectly. Everything's put together perfectly. Looks like I can't actually get that out, though, unfortunately, without cutting some stuff. So we're going to cut some stuff. Sorry, Internet, it's a feed-through. But is that not an interesting connector? And when I say interesting, I of course mean expensive. Okay. So now there's a board mounted perpendicular to the box bottom, and these appear to be the mounting screws for that one. All right. So there's the bottom of that. There's a piece of, I guess, just cardboard in the bottom there to help prevent short circuits and whatnot. It's a nice little case. I'm guessing they made a mold for that. It looks like there's a slight draft angle on the sides. So I don't know if that was pushed into something or due to the wall thicknesses not getting thin around the middle. They could have molded that. Expensive way to go. Okay. So 1980s tech. Let's take a look at that backside. That is so interesting. So back in the day, I mean, CAD programs haven't been around forever. Uh-oh. Sorry. Nah. There we go. Sorry. Wrong button. So back in the day, engineers would actually run traces. You have this tape that you would actually run across the board, and you'd make patterns. And that was your solder resist layer. Now that didn't leave great edges, so the next thing they did was they did the the projection. What's the name of that stuff? Basically where you project a pattern onto a board. And you do it that way, and that's what they did here. But check that out. You do not need your traces running in perfect, right angles. They can be straight lines, they can be curved lines. It oftentimes doesn't matter the least little bit. Not a bit. How cool is that? Cool, cool, cool. So, I mean, this isn't even... This is just interesting. I don't even know how to describe this board. This isn't anything that you would see today by any means. Especially all these multiple transformers. We've got 1, 2, 3, 4, 5. Maybe you see 2, but typically what they would do is have a multi-tap transformer custom wound, unless they're operating at different switching frequencies. I mean, you tend not to see that. I don't even know what these red-white things are. Are those diodes? I've never seen those before. But, I mean, a very interesting little board. Let's take a look at the next. This is the vertical version. It's got a little bit of adjustability on it. Power regulator 2. I mean, this is how you used to do it. I mean, when I was a kid getting started in electronics, you had all through-hole parts. You would lay out the traces on your board. You would connect them. I mean, of course, they did a much better job than I did when, I was a teenager, but this is how you did it. How cool is that? And, of course, my traces weren't so clean. Just little schmutz, it looks like. It moves. My traces all had rough edges, probably because I didn't properly deoxidize my copper. And it looks like this might be tin dipped to prevent further oxidation. But that is a cool board. It's an old school cool board. Huh. And then the wiring harnesses too are, this one isn't as good as the others. This was all zip tied, which they had to because they fed the wires through before they connected them. But it's still a clean harness. The thing that you're looking for when you make your own, you're trying not to distort the insulation and cut into the insulation. You want everything tight. You want you don't want these things all tangled up and going everywhere. It should be easy to trace a wire. And these things shouldn't cut in, which they did a really good job. I mean, maybe a little bit here on that yellow one, but not even. I mean, I would be okay with all of this. Hi, Ollie. Is that in your way? I'm sorry. There you go. Our friend Ollie Cat says hi. So anyhow, those are the 2 boards out of the high voltage section on the Canon camera. That's just cool. All right, we'll set that aside for a minute, and we'll keep going in. The next low-hanging fruit is our Aperture, and we'll take a minute and let that go back and forth as I open and close this. You can see they've got an inner and an outer aperture ring for some reason, and then there's a finger that goes off on its own and closes, when you, for whatever reason, if you want this thing completely closed, maybe sensor cleaning. What is it, Ollie? Hi, buddy. I know you're a good kitty. That's a good kitty. There you go. Cause trouble. Knock valuable things off my desk. But maybe we should take a second and talk about what the Aperture does to photography. And let's see if I was smart enough to bring a pen. I was. All right, let's see where I'm at on my screen. So when light passes through a lens, there's our center line on our lens. If I've got a little object like a person, right? Typically the way that we draw it is, we'll have a screen back here at the focal point. Typically the way that we draw it is that light from the top of the lens passes through the center and goes to the bottom. Light from the bottom of the lens goes through here and goes, from the feet goes through the center of the lens. And wherever the feet go, you have that. Wherever the head goes, you have that. And that's typically the way that we illustrate it. But that's not actually what happens. Let's forget about a lens for a second, and let's just talk about a circle, an aperture. Yeah, that's fine. Same setup. This would be a pinhole camera, so no lens involved at all. I've got a screen back here, and then I've got a object over here. Similar to what we had before. Well, here, instead of light going through a lens, you've got it going through a pinhole, right? Like a pinhole here. And you can actually, if you try this, or if you ever look at leaves on a camera, you can actually, if you try this, or if you ever look at leaves on a camera, you can actually get a little bit of an image going. We can't really do it here because of my light source is round, but I'm getting a round thing in that tiny little hole that I'm setting up in my fingers, right? There's something going on there. Well, what really happens is that light from the top of the head passes through to here. Light from the bottom of the head passes through to here. Those aren't exactly straight, but hopefully you get the idea. So your head ends up blurry and huge. The light spreads out. Light from the feet does the same thing from here to here. So I end up with a really, really blurry image. Well, we don't want blurry image. So what do? Well, you make a pinhole. You constrict the path that the light is able to take. Still the same basic setup. We've got a screen on the backside. We've got an object up front. Well, now the light from the top of the head, and I'm not going to repeat my mistake here. I need something that's straight so that this gives us a better image there. Or here, I've got a colored pin. That might even be better. Let's make sure it writes. There it goes. Okay. Well, now we're constricting the light that goes from the head and the light that goes from the feet to a much smaller area. This is what the aperture control on a camera does. So now I still have a little bit of blurriness, but it's nowhere near as bad. And the smaller the hole that you make, the greater the effect. So big hole, the light spreads out, blurry. Small hole, light comes together, not blurry. That's what this thing does. Unfortunately, it also restricts the amount of light that goes through, which means your image is going to be darker. You're not going to have as much light. But open, you get a very, very narrow depth of field. You only get a small area where it's not blurry. But it works well in low light. Here, everything is sharp and in focus from, really up close to really far away, but you don't get as much light. So you pretty much have to do that type of thing outdoors. All right, let's take this thing apart. So we've got on the front side here 3 screws that I think you can see. On the back side here, we've got a brass retaining ring that I think I'm going to pull first. There we go. And we'll see if that doesn't allow this to come apart. I haven't done any research on this, so I don't know exactly how it comes apart. That seems like it should have done something. But, like I say, whenever you don't know what to take apart, start with the obvious. In this case, we've got screws. And work your way in. Welcome to those of you that are joining us now. This is Mark Voids a Warranty. This is a continuation of a video I started last week where I took apart a ginormous lens, a broadcast camera lens. Okay, so those 3 screws are out. I don't know if that got us anything yet. Doesn't feel like there's any twisting motion that can occur there. Really feels like this is the thing that needs to come out. Oh, there was something fell. So we've got a internal rosette and then a drive. I mean, I don't even know what that is. Some type of a cam mechanism. It's not a Geneva's wheel, but it kind of reminds me of one a little bit. So this is the plate that drives those rings. And all it does is shifts back and forth. Oh, I see what we need to do. That screw's got to go. Bye, Mr. Screw. So the drive pin here, it's got a really tiny head on it. Come on, Vampires, it's your time to shine. There we go. Vampires. They've got teeth meant for doing just that, unlike other pliers. All right, so that drive pin's gone. Was that enough to allow that to move? There we go. So this is the outer housing, just a big pipe, for lack of a better description, although it's machined. And then we've got these slots in the Aperture drive ring, and all of these little windows or whatever they are, they move, you know, they fit in those slots. And they all get driven together. And it's all these tiny little pieces of plastic, with the exception of the one that comes out and covers that the hole. All of these have the same shape. So interesting. So anyways, I hope that describes what an aperture is, because the chances of me putting that back together are pretty slim. Could I do it? Eventually. Will I do it? Never. So, I mean, just the way that they built all this stuff amazes me. Even machining a part that is this thin is incredibly difficult, or at least difficult to do well. You know, it tends to be, you know, when you start trying to drill through this, you know, you've got this thing clamped down on a mill or whatever. It tends to want to grab and twist. So then, you know, you're a little better off with a lathe and pushing through this way, which is great. But then you've got to recenter it and then drill all those holes. I mean, man, it's work. And we've got, what, 16 holes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Where did I get 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 holes. Okay. Sorry. 36 degrees apart. So you can do that one without much work, but still. Interesting. All right. moving on to this. So this came out of a part of the lens. You know, this was, if I remember correctly, parallel to the optic axis, but it offset on the outside housing of the lens. And there was a right angle mirror and then another right angle mirror that would deliver it into the optical path. And we believe at this time that this is some sort of either a color sensor, a brightness sensor, or a focus sensor. But what it is, I don't know. So hopefully we're going to be able to get in here and figure out a little bit more. So the first thing that you guys didn't see, but I did, is this. On top of here were two cams, two little circles, and the circles had an offset pin in them. And if you would twist it one way, it would rotate the sensor ever so slightly this way or this way. And then if you twist the other one, it pulls it and pushes it ever so slightly forward and back. Let me see if I can do that on the bigger camera for a moment. So we've got these two little slots, and there were screws in the top of here that each had an offset pin. You twist the screw a little, it'll twist it left or right, and you twist the other screw and it'll shift it back and forth. So this was one of the adjustment mechanisms. And then you would lock it down with this little thumb screw here, and then it wouldn't move. So we're going to get into this. Looks like the first thing, oh, and then on the back side here, at first I was wondering what these are. I think these are coax cables. And I think this breaks out into, you know, 2 pin. So it really does seem like it's some sort of a sensor. But we're going to find out. It might take a minute though. As we go through, if you have any questions, please do ask. And then while you're watching, think of a few people that you know that might enjoy this content and share it with them. That's the only way this channel grows, is through your help. Because I don't market it. Let me grab, hi Ollie. Let's try these guys. That one's too small. This one's just right. So we've got a set screw there holding it could be the sensor. It could be a ferrule of some sort. Oh, there we go. There's something. Okay, so we've got, I don't know what we've got, but we're making progress. So we've got the electronic part of the sensor separated from the mechanical part of the sensor, the part that's the optical physics. Let's see, what can are those empty? Let's look on the camera. So we've got spots for set screws, but no set screws. That's interesting. Well, that explains why I couldn't find the right size. Don't think there's one in there either. Yeah, because I can see the threads right through there. So no set screws present. There is a screw there. That's lacquered in. This adjustment, whatever it is, H and V, horizontal and vertical, those look like they're lacquered in. So getting those out is going to be a little hit and miss, but I'm going to give it a shot. Once I realize where I put my screwdriver. All right, those of you out there in TV land, what do you like about Mark Voigt's warranty? What don't you like? What would you like to see more of? What would you like to see less of? And don't say me, that would be mean. Do you want more Fat Ollie in Chester? Do you want to see Fat Ollie put on a diet? Okay, so the H and V set screws are out. They probably only needed to be loosened, but we're not going to worry about that. Man, they're still stuck, though. I can't really do much to move those with my fingers. They do move freely, so they're just rough to rotate with that tiny little diameter with those thumb screws. But I can rotate them with the thing. Okay, so now on the front side here, I've got a bunch of tiny little baby Phillips. So we're just going to take those apart. All right, so I said something last time. I don't know if it's true or not, but I said this. Lenses have the ability to bend light's path. And then I also said that when you see something, what you're really looking at is a past version of it. It does take light a certain amount of time to travel. It is very, very fast, but it's not infinitely fast. It's a fast but finite speed. So whenever you look at something, you're looking at a past version of it. And the light, once it hits that lens, it does slow down a little bit. The frequency, the color of the light stays the same, but the speed of it changes as it goes through that lens. And since they're taking different parts of the light are taking different paths through that lens, you're seeing, if you think about it, different past versions. Some of the light gets to you a little faster, some of it gets to you a little slower, but you're seeing different past versions of the light. So lenses, just by the very nature of how they work, change history. How's that for philosophy? Okay. How are we doing here, Mark? All right, so we've got this guy. It's threaded on. There's no set screws, but it's threaded on. So I can remove that easily enough. Well, it's slow, but it's easy. Come on. There we go. Some of those screws allowed a couple of blanks to fall out. Did I miss a screw? I missed a screw. Oh, well. My bad. Okay. So two of the screws just held blanks in there. Now we get a little better shot of this optical element, whatever it is. So it looks like there's almost some knife edges they made. I don't know. I don't know yet. Let's look on the back side. Here, let's put it down here. What am I looking at? Looks like something with photolithography. I mean, I don't know how you'd make something like that. But part reflective, part pass-through. I don't know what those arrows do. Maybe give us an orientation. There's some lettering at the top. It says E605. I wonder if we unscrew it, if we get any more clues. If any of you out there know what this is, I would love to know. I'm going to be doing a lot of guessing here. Okay, I'm not really seeing any additional markings. It says E605. So how could this work? So I'm going to assume that these things have two functions. One is, oh, would that do it? Okay, so here's what I'm thinking. These things that kind of have some iridescence to them, I bet you they blur the light. And I bet you these other ones let the light pass straight through. Now, there's 4 of them because I assume you have 4 focal points in the lens image. So my thought is this. When light goes through these slits, and then light gets bounced around by the other ones, I bet you get some minimums and maximums. Either a minimum or a maximum in the light, the amount of light that makes it through at those 4 points. And with that, you can predict, by looking for a maximum or a minimum, you can predict the focal point. Now, would it be maximum or minimum? It would have to be maximum. You would have to be looking at a local maximum, I believe. Interesting. Okay. So then those pass light onto a screen. Oh, why didn't I look at that first? Here's why these things don't screw out. These are the offset pins that I was talking about earlier that you can use to adjust things. There were similar ones before on that. Okay. So now we're looking in here. And it looks like light shines onto a screen. And then we have our sensor. I wonder if I have a flashlight on me. We are going to find out. Ooh, that's going to be too bright for you all to see. So we've got a screen inside. I can't get to it. How do I get to it? Is that whole thing threaded on? I bet you it is. Come on. Oh, those things are galled. Okay. It's coming off, but not easily. Aluminum has a tendency to gall over time. Really rough threads. So I'm just going to keep twisting until it falls out into my palm of my hand. All right. Come on. Is that not enough twisting for you? Is it coming out? I mean, it's a very fine thread, so it could take a minute, and it is getting easier to twist, but I have to wonder if it's advancing at all. I don't feel like it is anymore. Now it's jamming. Okay, so there's a screen in there. I wish I could do more for you. Sorry, there's another lens element in there of some sort. I just can't get to it easily. I might have to Dremel it, and we've got other things to do. Okay. So out the back side of that, we had this guy. And this is what we believe, or at least I believe at this time, to be a light sensor of some sort. There's 3 inputs, 3 outputs. I think we just need to start getting into it and seeing what there is to see. Arg. Sitting on my desk right now is a spring. I don't know where it came from. That little guy right there, he escaped from somewhere. I'm not sure where. Okay, so that just appears to be a mounting screw of some sort. We're going to need something to pop these set screws. And I don't know what's in that light sensor. It could be something as simple as a photocell with a filter in front of it, or a photovoltaic with a sensor in front of it. Photons of, red, green, blue, whatever, would frequencies would pass through those band pass filters into, oh, neat, into this. So that's what I think this is. Let's take a look. No. Okay. Well, I was wrong there. I mean, it could be that my LED is too bright and there's light leaking, but these are just light pipes. These are just, these are nothing. My thought was the light would come through here and get split into red, green, and blue components and then pass through, but instead it's passed just through three. This is just a big fiber optic element. Well, it shows you. Oh, there's my filters. Suck it, science. Hughes wins again. There's the red, green, and blue. Okay, so I thought those were on that. Okay, so I'm okay. Then on the other side, these must be the photo. Wonder why they did it that way. Probably just the technology they had at the time. And then here are my either photoresistors or photovoltaic elements. So light comes through that thing, it goes into this thing, and then it comes out filtered red, green, blue. Neat. Okay, that's kind of cool. So that's a filter block. And then these, oh, we've got names on them. It says 3.5 volt 1, and I can't make out that other thing. Let me bring you in on them. 3.5 E11, 3.5 E11. So nothing special to them. They're only colored to indicate which filter block they plug into, and it looks like these are epoxied in, so I can't bring them out non-destructively. Let's take a look under the microscope and see if we can see anything, shall we? We can see my thumb. There's a huge lens on that thing. I don't know what all we're going to be able to actually see in here. Without pulling them out. A lot of crazing on the surface of that. A lot of crazing. I can't see inside at all. I don't think you guys can either. There's a great deal of magnification going on. And through all that crazing, I can't see anything. So, okay. Well, we tried. All right, so that is definitely a light sensor. So it's got to be looking for a localized maximum, and that it's got to be looking for focus. Brightness, if it was calibrated carefully, you could be doing brightness. I don't know. I would love to know. All right. Let's get back to camera 2. All right, folks. Well, I mean, a little more slow paced than the original lens teardown, but we got to see some cool things. We got to figure out that this is a little optical fiberglass doohickey. So we got to learn a little bit about how they used to do focus. I don't believe that's how they do it anymore. We got to learn a little bit about apertures. That was kind of fun. And we got to look at some old boards. Always fascinating. And I've somehow since lost them. How did I do that? I didn't even move. Oh, is that it? Yeah, there they are. Okay. I just covered them in my clipboard that I was drawing on. So we got to see some old school hand routed traces, which, I mean, old school cool, right? I like it. So with that, I hope you enjoyed Mark Void's A Warranty. Please make sure you tell your friends, tell your neighbors, tell your friends' neighbors, and tell your neighbors' friends. If you sign up, subscribe, and hit the little bell, you're going to find some new videos. And we've got one coming out next week that is hilarious, if I do say so myself. Really appreciate you guys joining me here today, and I hope you have a great weekend. That's it for me. We'll see you next